like them to do. I'm not sure. Usually it's places that are bringing in big research
And then,
money, you know, like.
and then, okay, great. We're going to stop bothering you now.
All right. Yeah. So this works?
All right. In theory, it's working. In theory.
All right. So.
Tell Dylan to check it.
All right. Cool. Okay. So.
Sorry for that.
All right. So yeah, that's the one thing I didn't do. Talk outline. So there'll be three main things, and there's a whole bunch of other stuff I can talk about if you want, but you know, whatever. Here's three things I'm planning to talk about, and I will try not to run into too much time. I'll talk about startup companies and modern manufacturing, which is a really cool concept. You're going to love it. Many of you have already seen me talk about it, so it'll be old hat to you. But I'll talk about what design, how to design it, and so basically, if you're going to go into if you're going to do a tech startup, how do you figure out what to build? And then I'll give you some sort of retrospective, my thoughts on what it was like to be in the startup industry. All right, so first thing, this is a slide that I throw up a lot of times when I'm just talking about random stuff on careers. And so the main thing for throwing it up is that to know what the startup industry is. So your career options, and so when you go into engineering the disciplines, you go into an R&D group, right? So you go into Intel or AMD or Florida Power or whatever. You go somewhere and they have an R&D group, and what that means is design and implementation. The truth is industry isn't doing much in the way of research. It's the R&D stands for research and design, but really isn't research. It's design and then implementation. Somebody does some designing of something that's going to be built, and then somebody else implements it. So right out of college, you can go straight into industry, in which case you're probably going to be on the implementation side. If out of college you go to graduate school and then go to industry, you will probably be on the design side. Simply because if you have a higher degree, they're going to pay you to do design. If you have a lower degree, you're going to be paid to do implementation, mitigated by the size of the company. If it's a gigantic company, they have PhDs doing the design. If they have a small company, whoever's best is doing the design. Because you probably don't have any PhDs and very few master's students. So it's mitigated by the size of the company. But again, if you have a big company, you need a higher degree to do the design work. Now, the difference between these in terms of salary is zero. You get paid the same amount of money. So you decide what degree you want based on what type of job you want to work on. But so right out of grad school, you can go to industry and do design. You can also go into research, like the labs, like DOE labs, Los Alamos. I work with people at Sandia, LLNL, and so forth. Or you can go into academia and teach. But then there's this other thing called the startup industry, which is you can go into the startup industry at any point. Okay, with a high school degree, with a college degree, with a graduate degree, and they're generally small companies that are highly focused, and everybody does everything, and they are really amazing. And the fun thing about them is they are a very collegiate atmosphere in that everybody tends to show, or everybody in the R&D department, everybody tends to show up around 10, 11, 12 o'clock in the morning, but we stay until about 2, 3, 4 o'clock in the morning. And so it's very much like probably what you guys spend your time doing in college right now, I'm guessing. Sure, maybe. Let's go with that. Okay, I'll go with that. You guys show up at noon and leave at 3? I don't know. Yes.
I'm curious. You mentioned that there's no salary difference between.
Not significant. Not significant.
Okay, so I've heard from different places that grad school generally leads to higher salaries.
It leads to higher starting salaries, but what's happened is grad school takes an additional 2, 3, 4, 5 years beyond an undergrad degree, and the undergrad is out there getting raises. So the undergrad goes out and is making, depending upon your degree, $80,000, $90,000, $100,000, 70. It depends on where and what you're doing, but somewhere in the $70,000 to $100,000 range. And with a master's or PhD, you'll be making like 90 to 120, 130, but you also stayed in school longer. So the guy who graduated several years earlier now has several years worth of raises. So the difference is less significant than it might look. Okay. You make a little bit more, but it's not like you get a master's degree, you get twice the salary. No, it's not like that, sadly. Let's see. But so anyways, so the main thing is that there's this thing called the startup industry. There's small companies, and everybody is doing everything. Everybody does design, everybody's doing implementation. There's very little hierarchy, there's very little division of labor, and in particular, they're really wonderful where because they are so small and because they are so, like they have this much work to do and this many people to do it, if you say, I want to do that to your superior, and your superior is like, there's one guy, the president of the company, and that's it. You go to your superior and say, I'd like to do that instead. And he goes, well, which one's more valuable to us? Okay, cool, that one's more valuable, do that. Because we can hire anybody to do what you're doing right now, you know? So this is, you can move up really easily, whereas in larger companies, way harder to move up because they've kind of pigeonholed you. They hired you to do one job, the job that they want done. And if you want to do another job, they're like, no, we kind of want you to do that one job we hired you to do. All right, so what, however, if you want to start your own company, okay, as opposed to going to somebody else's company? Well, there's a really cool development that's happened in the last decade, which is this world has become real, okay? The world in which you can imagine something, wave a magic wand, and bam, it appears. It's real, it's freaking cool, it's amazingly powerful. Okay, and I don't have a really good word for it, so I just call it manufacturing as a service. The point is that if you go back a ways, you know, if you wanted to build one of something, it's true today too. If you want to build one of something, you can build it in your backyard. You can build it in your garage. If you want to build 10 of something, you can probably, if they're not gigantic, you can build them in your basement, your backyard, your garage, or whatever. But if you want to build 1,000 of something or 100,000 of something, you've got to have a factory. So this is what they call barrier to entry. If you want to play in a particular market, you have to build a factory. And a factory is anywhere from $1 million, that's a cheap factory, up to like $10 billion for instance, a semiconductor fabrication facility. So 10 billion with a B. So the cost of building a factory is really significant. And so in order to just have a company, to make your first product, you have to first put a hell of a lot of money on the table to start that thing. You gotta build a damn factory. So this is the way it's been for years and years and years and years. Well, thanks to the internet, people who have put out the money to build a factory are really unhappy when their factories are not running 24/7, and they hang a shingle on the net saying, hey, we'll build your stuff for you. Because if they run their factory 24/7, they will like amass this massive stockpile of stuff. Generally the factory can make the stuff faster than their sales guys can sell it, right? So they don't want to make stuff 24/7 because they will have gigantic warehouses that just fill up with stuff, and they have to pay taxes on all that inventory. So they don't want to produce faster than they can sell, but they also don't want to have their factory down. So they'll build your stuff for you. They'll build your car. They'll build your laptop. They'll build a phone for you. They'll build woodworking, glass, metal, anything you can imagine, somebody will build for you. Really cool. Manufacturing has become a service. And it's like Harry Potter world is real, and the freaking the zapper is your credit card. You imagine the thing that you want, you give them your credit card number, and they ship you a box of the thing that you designed. Now, if that's not magic, what is magic? That's freaking magic, right? That means that you can run a manufacturing facility from your dorm room. That's powerful. It's really freaking powerful. Just cool as hell. Okay, basic idea. Here's you, you're sitting at a computer, you make a design blueprint, you send it to the factory, and they ship you the thing that you just designed. Obvious, right? You know. More complex things, it just requires multiple blueprints. Because whatever it is that you want them to build, there's like a set of rules that you have to give them. For those of you who are mechanical engineers, well, I'm going to show you what some blueprints look like. But you know, you've got the front side, back side, top side, or whatever. You've got the three-dimensional drawings that you're looking at and so forth, so that somebody can make an AutoCAD model of the thing. But for circuit diagrams, for printed circuit boards, you got to send them Gerber files. For making microprocessors and so forth, it's GDS2. Every single thing that you want to build, there's a specific type of blueprint that you need to be able to create for somebody to be able to build it for you. And you just make the blueprint, and you ship it off, and in a box comes the thing that you asked for. And if it's something complex, You just ship multiple blueprints to multiple factories, and all the parts go to an assembly house. The assembly house puts it together for you, and they ship it to you in a box. You know, and yes, you've seen the gravity things, right? You know, rocket ships or rocket packs are real. Yes.
How do you describe to the assembly company what you want them to do?
It's the same thing. You give them blueprints, you give them instructions for what to put together and how to do it. All right, so here are some blueprints. Here's the things that they created, this is what they created. These guys went into the back of the guitars. And the reason that I have circuit boards in here is because the wiring for these damn things was, I couldn't hand solder it and get it to work. It's embarrassing as hell. I kept screwing it up. There's a hell of a lot of wires, and they went to really small freaking places to be soldered, and I kept doing it wrong. I kept either fat soldering the joint so it slopped over into the next thing and short-circuited whatever, or I put it in the wrong place. I tried like 3 times. I finally gave up and said, this will never work. I can't do it. And then I realized, wait a minute. We solved this problem like, what, 5 decades ago? They're called circuit boards. You figured that I would have jumped on that first, but no, it took me a couple months to come to the realization. There's not a computer in here. There's no, active electronics. There's nothing. It just simplifies the wiring. It makes it trivially easy to do. And then I started doing some fun stuff like doing individual volume knobs for each of your 5 selector switch settings. Just weird shit like that. But yes.
So what you're doing here, is this just prototyping that you're doing with these circuit boards in your cars?
I sold them.
Oh,
yeah.
When you're in your prototyping stage,
I'm going to talk a whole lot about prototyping. What do you want to know?
Well, basically, I'm curious what kind of batch sizes do you need?
Well, we'll get to that. So here's some other blueprints, and those of you in mechanical engineering realize, yeah, this is exactly what you send to somebody to get something made in 3 dimensions. And I had people build the, you see, this is what came out of it. Oh, and these guys, yeah, they're here. I haven't shown these to anybody yet. But I'll pull these guys out later. But so this guy and then that guy, 2 different colors of the same thing. So they're cool. Don't you fall. That would suck.
That would suck. That would break my heart.
Yeah, that's okay. So anyways, some blueprints, and then here's what they turned out. And this is the one that I left at the house and forgot to bring. Oh well. So anyways, so I had other people build this stuff for me. I didn't build it. I designed it. Other people built the guitars for me. Other people built the circuit boards for me. I designed the circuit boards. They manufactured them. I designed the guitars. They manufactured them. I just put everything together and then I sold them. All right, so Professor Jacob, I can't possibly compete with big companies. Yes, you can. Sort of by definition, big companies want to look at big markets. They're not interested in doing anything that is going to make them less than $100 million a year. Why? Because they have to dedicate the manpower to it, and they have to be willing to support that market for like 10, 15, 20 years, because if they don't, it looks bad. If they enter a market and then pull out, it looks really, 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 really bad, and they lose a lot of customers. So they have to say, all right, we're going in this for the long haul. They don't want to make less than $100 million. Well, that means that if you're interested in a market that's smaller than about $100 million a year, like if you're willing to make only $10 million, that means that you can find a lot of markets that nobody else wants to go into. You will be competing against other startups. You just won't be competing against big companies. You won't be competing against Microsoft or Apple or Intel or whatever. All right, so the idea is already proven. Oh, Professor Jacob, I might fail. No. It's a win-win situation. If you succeed, awesome, you succeed. You start making money and you're happy. Even if you fail, if you start with an idea and you develop a prototype and you test it and you go through, compliance testing and you do some marketing and you throw it out there and it fails for whatever reason, you've done all of this work that other people haven't done, which means that you're going to look really good to anybody recruiting for Intel, AMD, IBM, Microsoft, Google, whatever. Anybody who's hiring is going to say, wow, you've got a lot of experience. Tell me about it. You're going to look like really good compared to somebody who's never even tried it. So the experience is worth gold. Oh, Professor, Jacob, I can't afford it. No, no, it costs you nothing, because remember what it costs to actually build a factory. A lot of money. This is something where, all it costs is a laptop and an internet connection. And then you're going to pay the per unit cost for the things. Now, here's where the price differential comes in. Let's say that, you're building a car, I don't know, a car that you think that you could sell for $15,000. I'm just making up a number. 15 grand. If you had a factory, you could probably manufacture it for, I don't know, say 10 grand. And you could sell it and make 5 grand. They're going to charge you, say, 12 grand. So you make 3 grand, but you didn't have a factory to build. So you'll make less per thing, but you didn't have a factory. I'd rather not have a factory, frankly. So, and if you're building cheap things like software's, the cost of a per bit is 0. For software, it's the cost is nothing. So the upside is really good. I'm sorry? Yeah. So I think that the window of opportunity is everybody's starting to realize this. This is why, like Apple says, designed by Apple, on the back of their devices and on the underside of their laptops, they all say designed by Apple in California. They know what's valuable. Design. Don't try to fight other people on manufacturing costs, because somebody will always beat you on manufacturing costs. There's always somebody who will do it cheaper. What you should do is try to design better stuff. That is something that you can't pay someone to come up with better designs. If they can either do good design or they can't do good design. You can't say, hey, here's $10 million more, do a better job. And they're like, well, I already gave you as good as I could do. Yes, sir.
Okay, the question is, if you can't pay someone to do good design, how do you get somebody or you yourself to do design?
Gonna get to that. You're either brilliant or you iterate. I'm gonna get that's actually exactly what I'm about to do. Oh, and by the way, so as far as costs go, there are plenty of other ways to figure out how to pay for your thing. Kickstarter, because this is a great way for you to figure out if people are actually interested in your product. Are they willing to fork over money for it? Here's an example from Kickstarter. This is a high-tech example. This is Adaptiva. These guys built a frigging chip, a CPU chip, on Kickstarter. Holy crap! That's cool. That means that you can do frigging anything. Anything. You just have to have a really good idea, a really good video, really good initial implementation. There you go. And if you hit the right people the right way, you got to show them, hey, what I'm doing is something you need. And that's a hard problem to solve, and I'm gonna get into that just to get you to think about that. All right. So next is, what should you design and how should you design? Now, this is going to get to your question. This is going to answer a couple different, well, not answer. It's going to raise more questions than it answers, and I apologize for that, but I just want to get you thinking about it. So first thing is to figure out, okay, well, I want to build stuff. What should I build? What should I design? So the first way to think about what should I build, what does the market want? Look at what's broken. What are things that annoy you? What are things where you're like it's uncomfortable, or it's like it takes too long, or it doesn't work right, or it breaks easily, or whatever? Things that annoy you, that's your brain telling you in a subconscious way, I could do it better. Your brain has already figured out a solution that's better than what you're looking at. It just hasn't propagated to your conscious mind yet. When you get irritated, remember it and try to pay attention. Like, why am I irritated? What am I irritated at? Is it the design of the chair? Is it the design of the wall, or the handle, or the guitar, or the sound of something, or what? Your brain has figured out, I don't like that. And the reason it doesn't like it is because you can do it better. So pay attention, write it down, think about it. Because your brain's working on this stuff in the background. And like, here's an example, like anything where if you forget your password, you've lost $100,000 is probably a bad system. But again, I think they've solved some of this to a degree, but anyways, it's, it can be made better. All right, here's a harder thing, figuring out what's needed, okay? Because if you ask people what they want, especially if you have like focus groups or something like that, people will tell you what they want. But oftentimes what they want is not what they need. Yes, sir?
Henry Ford said it.
Oh, rock and roll.
Henry Ford said, ask people what they want, they say faster horse.
Yeah, there we go, exactly. You hear this? Henry Ford said that if he had asked people what they wanted, they would have said, I want a faster horse. Ah, exactly. Steve Jobs is a brilliant example, a current example of a guy who time and time again gave people something that they had no idea they needed. They thought they wanted this, and he showed them, how about this instead? They go, oh my God, that's what I want. Yeah, because he could see things that other people couldn't. So this is a really hard problem, and here's just one example to illustrate how hard this is. This is a story that was from The Economist about 10-ish years ago, where there's this region of Eastern Africa where it's like 200, 300, 400 miles of coastline, where the primary food source was fish. And when I get done with this, we'll actually, want to eat now? How many people are hungry? All right, I'm gonna finish this one story and then you guys eat, and then I'll start talking. All right, so here's the thing. So there's this region where everybody was starving, and I'm gonna talk slow so you understand about starving. So anyways, there's this region where they were starving. The primary food source was fish, and fishermen were going out in small boats, and you know what fishing is like. You either come back with a lot of fish or you come back with nothing. It's just like farming. You either have a boom year or a bust year. It's very much you're at the vagaries of the weather and the tides and whatnot. So fishermen would either come back with way too much fish, and fish would sit rotting on the docks because people didn't need it in that particular village, or they come back with nothing and people would be starving. Okay, this is a massive problem. Now, if you put the world's smartest people into a room and say, solve this problem, what would they do? They'd talk about airlifts and let's have technology that follows the fishes and tells the fishermen where to go, and let's do some weather balloons that, talk about fish masses and feed, let's dump food into the water so we can direct them to certain locations. They'd be talking about all sorts of solutions to the problem. Guess what the problem ended up being solved by? Telecommunications. Once it became cheap enough, once telecommunications became cheap enough such that the fishermen could afford to buy a cell phone, the problem went away. Because the fishermen went out of the water, and if they had a huge cache, they called up and down the coast and said, who's paying the most? And they went there, because that's the place that needed it the most. So it was a distribution problem that was solved by telecommunications, and I guarantee you there's not a person in the world who had said, I'm going to solve that problem through telecommunications. I'm going to give everyone a cell phone. No, nobody could foresee that. That's a hard freaking problem to solve. Yes, sir.
I was gonna say, there's a simpler way to solve it without using technology. Because this is kind of a storage issue. I would say just dig a hole and put the fish in the hole.
Exactly, make a fish tree.
Yeah, or salted fish.
Yes. Well, okay, yes, exactly. But I don't know why I don't know why the preservation wasn't an issue. Okay? But I mean, this is what was going on, and the problem went away. So, hard problem. Figuring out what's needed is hard. It's really damn hard to figure it out. And when you ask people, they will tell you that they want a faster horse. Okay, have some food.
It's true,
I'm kidding. Pizza that you can't eat.
Hey guys, question.
I'm sorry?
I'm Dylan, sorry.
Good engineer.
I'm sorry. Sorry.
I'd like 36 cents.
Not 36 cents.
I'm rich.
Thank you for getting all that.
Yeah. Did you get Teams running?
They said they got stuff working. So.
Okay, cool.
Didn't connect the Wi-Fi, but fortunately I have a USB-C adapter because Surface.
Great, love it. So I could get that recording.
Everything's working on.
I noticed you ended up mentioning Kickstarter on that, and I guess you're not necessarily mentioning angel investors too much in this.
I'll get to that. I'll get to that in a moment. Yeah.
Doesn't Kickstarter tend to land you in a very weird situation when you start trying to look for angel investors if you use Kickstarter?
That I do not know. That I don't know.
As far as most of my reading has gone on this particular topic, it looks like in order to actually receive the Kickstarter money and start using it for R&D and actually developing the company, you actually have to incorporate that as some sort of liability corporation,
Okay.
which you start running into problems when you ask for angel investors because they usually tend to ask you to reincorporate as an S corp. And I know there's a few issues there, but
Yeah, that's beyond me. I don't know about that, but I will talk about venture capital. So yeah, this is
Your electronics.
yeah, and so the final design was.
And these are all designed by you, manufactured by someone you sent them off to manufacture.
Yeah, well, they made the circuit boards, but then I soldered them.
That's still a good amount. You use normal solder or like the air soldering?
Just regular,
I've seen-
just regular.
Yeah, someone I was working with designing some battery closures, like assembly batteries, use air solder for charge controllers.
Okay. Yes.
What did you first manufacture those boards?
Circuit boards are easy. There's like a gazillion of them online. They're like 4PCB.com, sunstone.com, I don't know what else is out there. Those are the guys that I used 15 years ago at this point. But everybody's got a circuit board manufacturing, and they'll do like, bendable stuff, It's absolutely wild what's out there. It's really cool.
So like bendable circuit board?
Yeah, flexible, it's called flexible PCBs. Yeah, they're really cool. They're for putting in like clothes and stuff. It's like, all sorts of wild things out there. There's some really good technology.
doesn't bendable PCBs have like issues when they repeatedly bend though?
I wouldn't be surprised, yes, because you got copper in there. Or at least presumably you have copper. Frankly, I don't know what they use in there, because if you're using something that is, too metallic and not moldy enough and bendy and malleable enough, yeah, you'll start developing cracks over time. All righty. So you guys want? I'll keep talking. All right, cool. All right, so.
Thank you for the pizza.
You're welcome.
Thank you.
So, very welcome. All right, so how to design. All right, so here's some thoughts on how to design, and here's where the sort of the examples come in. You're either brilliant and you can come up with, a genius design on the first try, or you're like most people, your first design will suck. It will always suck. The first design will always suck. First version will always suck. Just get that into your head. And the thing is, we're human, and so the first time you make something, it's brilliant. It's genius. It's the best one that's ever been made because it's the first one you've ever made. And you're like really proud of yourself. Look at this. I made this. This is cool. This works. It's great. It sucks. And your job as a designer is to stare at it until you finally start realizing the ways in which it does suck. Okay? And then the second version will also suck. Fix it. The third version will suck less. Fourth, fifth, 10th. Round about the 10th version, you will have something that's really freaking good. Oh, you're bad. All right, so for instance, Chris, we're gonna have to kick you out in a moment. So here are our designs in order of sort of crappiness. This is the first version. These guys were the first versions made by a Chinese company that gave me a spray-on sunburst, and it just looks like crap. And they didn't give me a net-through design, which I asked for, and they didn't give me my the what do you call the vinyl lay that I asked for. I'm sorry?
You had these manufactured, you
Yes.
went out to a job company and wrote, okay.
Yes, yeah, I found ghost manufacturers, and went to, and so this company, it kind of sucks. This was the second company that I had built, and this is the company that ultimately I went with. They built this. This is the final version. This looks like what was sold. This is basically what was sold, and this is what was sold. So this is the first version, last version. So you see that there's some design iterations. The first one sucks, the second one sucks less, the third one sucks less. Here are some of the things that that we did. So Nobody can read the headstock. Nobody has any idea what the logo says because it's so damn small. Nobody can see it unless you're right up on the thing. So the second version, I made it bigger so that at the very least, people in the front row in a bar could read, you know, the headstock of my guitar. I want them to see what kind of guitar is he playing. What else did I do? The finish, well, yeah, the finish sucked. This finish was right, but they made the binding wrong. They did the binding right here. What else? The finish is, yeah, and this is another company that we tried, and their finish sucked too. It sucks less than these guys, but it still sucks. Size of the body. So you can see small, medium, large. We were playing with the size of the thing because if you play guitar, you know that the guitar wants to do this. You want the guitar to do that. It wants to do that. There are a couple solutions. One is you make this horn longer, like that guy over there. The second is you make the body larger. There's another way. There's another one where you basically you move this strap button closer to the bridge. But you know, so there's a couple solutions to the problem, and so what I did was I was experimenting with you know, trade-offs between how big it is and how sucky it looks. You know, because obviously at some point you make it so big it looks dumb. So I was just basically trading off, you know, the size of thing. And here's that I finally did a free body diagram to figure out what was going on. You'll notice that anytime people have weird stuff going on in the bottom of the guitar, they always put the strap button off to the side. In the first version, I did too. And then I actually did the free body diagram to see where's the best place to put it. Turns out, as close to the center of mass as possible is the best place to put it. And I figured, you know, I should have done that first. So, final version, strap button is where it should be. Let's see, what else we got going on? Thickness of the abalone inlets. So if you go up to my office, you'll see I've got a double neck up there where it's got inlays that look like this, and they're really, really wide and they look stupid. So I made them a lot thinner, and it actually looks cool in this version. So, you know, I just basically played with a lot of different things because, you know, first version sucks. You know, keep working on it. And at some point you just say, okay, I've done enough iteration. It's good enough. I still see problems, but ship it. Yes, sir.
So, the first four are prototypes, is that correct?
Yes. Well, this is pretty much what was sold. Only this is the master that they went by. So this was handmade by a guy in Korea. The final ones that were sold were made by the guys in the factory, and I think the factory was actually in China.
Okay. How relatively, how expensive was it to get these prototypes? Just for your
The prototypes were expensive because, you know, basically you're paying a couple, like each round of prototypes, and I would get like, you know, 3 or 4 guitars made. It was about like $4,000 or $5,000.
Okay.
But when I finally got the guitars that were made in the factory with a case, you know, shipped to me, the cost of doing international shipping and paying all the customs and all the crap, it wound up being about $450 per guitar total, and the starting price was $999. So.
Okay.
Sorry.
You said $999 like a decimal point between $999.
Gotcha. Circuit board design. So I went through a gazillion, you know, this is sort of the final circuit board design. It was kind of neat. It's, you know, each piece has its own circuit board, and they're all connected through ribbon cables. If you've ever looked in the back of a guitar, it looks nothing like this. This is really simple, and it's sort of idiot-proof to make. It means that even I can solder it and make it work right. I have a patent on this, which was kind of cool. But, you know, I went through a gazillion different, you know, since these, it costs about $100 or $50 or $20, depending on how many circuit boards you buy, to do one round of iterations. I went through about 20 iterations of the circuit board. An interesting story is that, you know, this is you know, the typical for a circuit board. You know, you make them rectangular, they're the ugly ass green. And we took them to the NAMM trade show, and I was showing people, you know, what was going on. And like I told you guys, the only thing that these things are doing is simplifying the wiring, because it's a hell of a lot of wires. It would be a rat's nest of
Yeah,
spaghetti.
at least like 3 or 4 wires in that one.
Yeah, it's a hell of a lot of wires, and here, you know, you still have a handful of wires, but it's nothing like it would have been. The connections between the two, you know, I got a ribbon well, anyways, if I showed you the diagram, you'd see, oh my Lord, that's a lot of connections. This simplifies it tremendously, and that's what they're doing in there. But people freaked out because guitarists really don't want you to put active electronics in their guitars, working guitars. Like engineers, you guys be like, cool, give me some active electronics. But these guys didn't. You know, working musicians, they don't want you to screw with their device. Like, oh my God, you have a computer in there. No, I don't have a computer in there. I just have a circuit board. Oh, you got active electronics. I don't want a battery. No, there's no active electronics. There's no battery. You got a DSP. No, there's no DSP. There's no chips. There's no, oh my God. Ah. And they all freaked out. It was like, oh, Jesus, what's going on? Ah! So I did two things later on. Instead of making them perfectly rectangular, I made them like curvy on the edges, you know, sort of smooth. And I used a black finish instead of the ugly ass green finish. And the next time I showed them to people, they go, oh, cool. Like showed them like this. No. I showed them this. And they go, oh, cool, you're using circuit boards. So evidently there's something in this that just triggers the hell out of people. So, you know, yes, sir.
So for you as a designer, how much of your design process in these guitars, or I should say, if you think about these guitars, in your opinion, how much of the value of your guitars over other guitars comes from the things in the body of the guitar itself versus like the electronics that you put in?
Well, I don't know. I just this came to me because I bought an Ibanez artist that was this shape, and I thought that it was going to be a good guitar, and it was a piece of garbage, and I was really disappointed. And I bought a version of it from the 1970s off of eBay, and it was brilliant. The modern version was crap, and the one from the 70s was excellent. And I noticed that not long after I bought it and then sold it, Ibanez stopped making that design. And I loved this shape. I was just like, this is a really cool shape. This was Ibanez's first original design, and it was played by Steve Miller. And so this is the thing that previously they did like Gibson knockoffs and Fender Strat knockoffs. And this was their first original design, and for whatever reason they stopped making it. At one point they tried to make it such that this horn was asymmetric, and it just looked stupid, and nobody was buying it. So that's one of the reasons that they got rid of the thing, because it doesn't have great balance, and that's what we realized too, and that's why I used the bigger body. But I noticed that people on eBay were buying these guitars from the 70s for like $800, $900. I'm like, holy crap. And what was interesting about them was, you know, they looked really cool. They had ebony fretboards. They had, you know, dual humbuckers that were pretty good. And they had, you know, book matched tops, but they kind of looked like this. They were not really high. They weren't high grade, you know, they weren't quilted. They were not even flame. They were just maple, you know, they're carved maple tops. But you know, that was basically it. And some of them had some extra electronics, and people were paying like $1,200 for those. And so I thought, you know, gosh, if people are buying that for, you know, $800, $900, $1,000, I can sell a brand new guitar for $1,000 if I've got ebony fretboards, really nice tops, abalone inlays, you know, decorative inlays, because that's considered high end. It looks really cool. Theirs had like just dots. And if I put really cool electronics in there and really good pickups and all that stuff, I mean, I should be able to hit that market. That, you know, people are showing you with their wallets that they want that thing. And if I just give them that shape of a guitar with all this stuff, they'll buy it, and they did. So.
How did you know that market was going to stick around even as long as it took you to go through the whole design process?
I guessed. The markets don't shift too fast. Okay. So that's changes in the PCB design. Here's the logo on the case. This is sort of like the mascot. This is the sort of logo of the company, and there's coil guitars in this similar sort of Illustrator thing. You know, you can see that it's the same. The logo. Well, actually, you see it better there. That's what the font looks like. But when you see it on like the website or something, it's sort of, you know, I forget the Illustrator. effect that's used, but it blends the thing in. And when they were going to silk screen the logo onto the case, I told them just make it solid because it's hard to silk screen something that's like grayscale like that. So so I just had them silk screen the thing as just a blob on the case. And then when I got this, I realized that looks like a massive bird shat on my case. So I changed it, and this is what we shipped. Okay, so the first version always sucks. First version always sucks. Okay, so don't be afraid when your first version sucks. When you're, because you'll think it's genius, but stare at it until your brain finally realizes, oh, I'm starting to see errors or problems or things I can make better. So, all right, so first version always sucks. Now I'll talk a little bit about software. So this is technology. I talked about low technology now, and actually now that I've got, let's show you the good stuff. So I can be proud of this. These are, I just throw these around because I let my students in Maryland chew them up and drill holes and use them for experiments and stuff. So that's why they're all beat to hell. All right, so let's see. Let's see what we got.
Actually doing this for entrepreneurship, this is free advertising.
Yes. So this is my one really truly original design. This was sort of like a there's a company called Alembic that makes a bass. It looks kind of like that. They do that thing. It looks like a sort of cross between a violin and a guitar. So I kind of stole that from them. But this is the one original thing. So I did 2 different colors of that. Anyways, so first version always sucks. I worked for a company called Boston Technology, and they had a distributed system where the distributed system is controlling a telecommunications device. It's a voicemail machine. But you can imagine, how would you build a voicemail machine? Well, you've got a massive number of external telephone lines coming into a switch, PBX, private branch exchange. So that just means a small switch that you control as opposed to the telephone switch that the telephone company controls in one of their local offices. So there's a switch, there's a switch inside this building that controls all the, are there any phones here? Well, there's phones in all the offices. What?
IT phone from there.
Okay, well, there we go. So there is a switch in this building to which those things are connected, okay? And that's the way all buildings work. You buy a switch so that you can connect your phones to it. So the external world comes into your switch. All right. So here's how voicemail works. What they've got is a whole bunch of VPUs, voice processing units. So these are like boxes in a rack, and each one of these things has one or more cards in it that are talking like T1 or T3 to this. This is talking like T3 or T5 to the outside world. So you got hundreds to thousands of individual lines coming in here. Dozens are going to here, dozens are going to there, dozens are going to there, if that makes sense. Each one of those things is a digital, phone line. So the way it works is a call comes in, the switch tells your control device, hey, I got a call coming in on line, blah, 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 whatever. This guy then tells the system, hey, pick up that line, and he tells the PBX, route that incoming call to that line right there. Okay, and that's how it works. And so you get the external world talking to this, and you tell the software running on this guy, hey, pick up the phone. Pick up the phone. You're controlling a hardware device that talks to that digital telephone line. And you say, pick up the line, and then you play a prompt. You play an audio file out the thing that says, you've received what did they say? Boston. You've reached. Thank you for calling Boston Technology. If you know the number of the party you're trying to dial, please press it now. If not, okay. So anyways, you get a prompt. and it, and if you know what you want, the thing then is like, then you say, listen for digits, and the person goes beep, 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 boop. You go, okay, what do you dial? 3459. Okay, this guy says connect to exchange 3459. This thing now takes that call and routes it somewhere else, either to the guy's phone or whatever. But you can see how these things work. It's pretty straightforward. All right. So the way that Boston Technology, their system worked was there was a master device that had to know the state of every piece of software in the system. And when a call came in, he figured out, okay, I'm gonna send it to that guy. Okay, that was just the way it worked. I went to work for a company called Priority Call Management. And a guy at Boston Technology said, one of the weaknesses of the system is that this guy has to know the state of every piece of software in the system. And it turns out that sometimes the state gets out of sync. So he would think that this guy had hung up and was ready to accept a new call, but he's not. And he'd send a new call his way, so have you guys written C code and like open files and close files and write them and read them and that sort of thing? Have you done that in C? Okay, so sometimes when you're talking to devices as opposed to files, you try to close it, and you gotta wait for that device to say, okay, I'm closed. Only then does your close function call, the system call, only then does it return. So you can imagine, you're supposed to close the file out. It takes like that, you're done. All you have to do is close it. If you're talking to a device, closing it down takes as long as the device wants it to take. And that might be a nanosecond, it might be a microsecond, it might be a millisecond, it might be tens of milliseconds. Okay, so this guy, if this guy thinks that you've hung up and a nanosecond later sends you a new request, but you're still holding on to that line because it hasn't actually hung up, and he tells the switch, hey, route it to that guy. Well, the software is not ready to pick it up, the hardware is not ready to receive the new call, everything goes to hell. And this is something that they realized was going on while I was at Boston Technology. Because, I can go into what testing is like in a small company if you want, but testing is really fun. Like, we used to sit in a room that was half the size of this, and everybody would have 3 or 4 phones sitting in front of them, and the guy would go, okay, everybody go off. We just pick up the phones, we just start dialing and talking into both of them and recording and we were trying to simulate lots of people using the system. So like a dozen people could pretend to be 48 lines. It's like, oh God. So that's honest to God, that's how we tested Boston Technology stuff. But what would happen was, little by little, these things would gradually decay because there would be lines that would just go off and they would never be able to be reset. And so you'd have to periodically reboot the whole damn system. So I knew about this. And there's this guy at Boston Technology, when I went to the new company, he said, you might want to start with that problem first. Okay, I will. So the way that I changed it was, instead of having the main guy in charge tell them what to do, I had everybody, when they're ready, ask him for work. See the difference? Now becomes
time and delays a lot easier.
I'm sorry?
You can build time and delays in.
Well, you can just ignore the time delays, because basically however long it takes for these guys to hang up, get the signal that's done, actually return from the system call, and then get back into normal processing, and they're ready. And everything is cool. The hardware is ready, the software is ready, nothing hangs. And it becomes a client-server environment. I'll show you that in just a minute. Yes?
So the VPUs you made it so that the VPUs would be responsible for managing the call that they're on instead of...
To an extent.
Okay.
They would ask for work. They would say, here is what I'm capable of doing. I can do this service, that service, that service, that service. But I can't do this, but they would list out, I can play like the welcome service, Thank you for calling Boston Technology. If you know the number of the party you're trying to dial, blah, 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 please press it now. They could do voicemail, they could do whatever, but they couldn't do things like paging. They couldn't do, whatever other functions. But the idea is that you have a body of software, and it knows, okay, I have the following functions, so I'm going to register these with the scheduler every single time. I'm going to say, I have these following functions, and I can do those things. I can't do anything else, and so then you would just basically say, I'm free, and I can do any of these things. Do you have any work for me to do? And it would either come back, yes, do the following, or no, I got nothing for you to do right now. Try again later. So this is the big picture. This is what the Boston Technology System looked like. You have a whole bunch of these, and so inside of VPU is basically you had a port daemon, we'll just call it that. You had a piece of software that was running constantly in the background. It was talking to telephone hardware that was connected to the switch. So you had like 24 of these port daemons, or 48, depending upon the design of the thing. But you had some number of these port daemons, each of which had its own dedicated hardware that was wired up to the PBX. And you had a bunch of these VPUs, and their central control is called MOMD. And the switch daemon would get these requests, and the switch daemon would say to MOMD, I've got a call coming in online, whatever. And the MOMD would just say, you take it, and then tell the switch daemon, okay, route it to that guy. Okay, so that's it. That's the way it worked. But you can see who's the client and who's the server here. Here, this guy tells him, I have a request coming in online, whatever. These guys are saying, do you have work for me to do? Do you have work for me to do? Do you have work for me to do? Oh, cool, you've got work for me to do. And when he says, okay, I'll give you work, it goes back to that guy. That guy is told to pick up the line. Meanwhile, he tells him, route the call to him. Now it should be clear, client server is real here. These guys are clients of this guy. This guy is the server. They're all trying to get his attention. And if he gets backed up and their message doesn't get through, who cares? It doesn't matter if they don't get through, because if it's busy, well then, he's just trying to hand off work to everybody. Okay? Whereas here, this guy is the client of these guys. They like turn client server upside down. That's why the system broke. Okay.
So in the new design, with the port daemons, would they just wait until the scheduler could take their?
Yeah. They would just say, give me something to do, and it would come back. I don't have anything for you. And then they would wait. They'd say, okay, give me something to do. And then in later designs, what he did was he would tell them how long to wait until trying again. So instead of like everybody's constantly going, give me stuff, like in an idle system where you've got like no calls coming in, these people are going, give me. It's just like the whole network was flooded with requests and then nothing coming back. And it was just like the network was just filled with messages that were nothing. And so if there was very few calls coming in, this guy would say, oh, get back to me in a millisecond. And so he would just do this online calculation. So he'd basically have, there would be a constant, more or less constant rate of requests coming in such that you could handle busy hour calls of like, 10,000 busy hour calls. If you say 10,000, that's like one of the magic numbers. Can you get to like 10,000 busy hour calls? And so do the math. If you want to do 10,000 busy hour calls and take, an hour, divide it into 10,000 pieces, that means you got to pick up the phone line once every that amount of time. And so that's kind of what we did. We said, here, give me a new result that way. So you'd say, how many port daemons do I have out there? Do I have 12, 24, 412? How many do I have? And let's just divide the time by that until you get back to me in that amount of time. And so stuff would come in at a more reasonable rate. All right, so if you look at these things, the Boston technology scenario was basically as a push scenario. MOMD was responsible for everything. He was responsible for finding a process to do the work, keeping track of everything, and if the global state that it thought existed was out of sync with the actual state, everything screwed up. MOMD was a critical link, it was a bottleneck, and it was responsible for everything. If MOMD screwed up, the whole system started to go down. It was a problem. So what we did, we turned it to basically a pull thing. This MOMD thing, I call it the scheduler, it's basically a bulletin board. The switch daemon basically posts things on the bulletin board, and all of these processes register with the scheduler saying, hey, do you have anything for me to do? It's like you walking up to a bulletin board and say, oh, cool, I can do that. A job board. That's basically what it was. It was a job board. So the processes periodically ask for work. It's like the difference between interrupts and pulling you want, I can talk about that. But the thing that, the equivalent of Momdi is responsible for very little. It's just a clearinghouse. It accepts requests and hands them off, and that's it. It does nothing. It doesn't even keep track of state. It could care less of who's doing what. It just knows that I have a list of things that need to be done. And I have people registering with me saying, I can do the following things. And it just says, oh, can you do the first thing on my list? Cool, here you go. Another request, can you do the first thing on my list? No. Can you do the second thing on my list? Okay, here you go, bam. That was all it did. And as a result, we were able to do 10 times the call throughput of Boston Technology. It was awesome. Made Boston Technology really angry, and Boston Technology then went and sued the hell out of priority call management for stealing their employees and stealing their customers, and by that, yeah. Well, I was gone at that point. I was in graduate school by the time all that happened.
He got it.
Yeah. So, anyways, the first version always sucks. Okay. First version, even when designed by frigging brilliant ass people, the Boston Technology system was designed by really smart guys, still sucked. Still had massive problems to solve. Okay? And this was not their first design. This was their nth design. And it still had massive, we were able to beat it by a factor of 10. First version always sucks. You can always improve on your design. And your job as a designer is to stare at your design until you start, your brain is going to explode and you go, oh my God, you start seeing the errors and imperfections in your own work. We're not good at seeing imperfections in our own work. This is why editors are a thing. People who write copy, somebody else edits it, because if you look at stuff you write, oh, it's genius, it's perfect, I know what I'm talking about, and somebody else reads and they do, this sucks. This is why editors are valuable. Okay, but for technology, it's hard to have somebody who's an expert in what you do looking over your shoulder and say, dude, that sucks. It's hard. You have to be the person to find your own imperfections, and it's really hard.
Oh, man, I got a lot of those.
Yeah. Well, so if you can see it, that means you're humble, and it means you're good at doing stuff, and keep on it. Keep doing it. Okay.
Or that.
All right, so last part. Oh man, I'm running way over, I'm sorry. So here's some really good advice. There's this guy named Paul Graham. This is a guy who was in the early ages of the internet. Well, actually, no, the early ages of the web. This is like, the web became a thing in the early 90s. You guys are probably not even alive at that point. With like Netscape and so forth. There was a whole bunch of stuff. I can talk about that if you want, but the history is kind of cool. But the web happened because of a confluence of factors which were really hip. It's basically Netscape got onto Windows and basically normal people like housewives and people with PCs at home had interaction with the internet. Up until that point, nobody used the internet for anything. Mail existed, but nobody used it. I mean, I had it when I was in academia, but I didn't use it for anything. Nobody used it for anything. It wasn't useful. It was hard to use, and you couldn't. The only place where you had an internet connection was on an academic campus. But once the web started happening, and it made it to the general populace, because originally, you guys know, it was developed by scientists for sharing data. Once it made it to normal people who said, hey, wow, let's get on the web. You guys know there's a book. I have it in my office if you're interested, The Whole Internet Catalog. There's a book, yeah, you get it. The Whole Internet Catalog. It describes every site on the internet.
Because there wasn't Google and there were only a few thousand sites.
Thank you, yes. You can come by and flip through it. It's really funny. Because there was a time when the internet was small enough that you could fit every site in a book this thick. Anyways, so once the web was a thing and people had the web on their PCs at home, guys like this said, normal people are going to want to create websites, but normal people don't want to write HTML. Normal people are also going to want to. Some of those normal people are also going to want to sell stuff on the web. They probably really don't want to write HTML. Let's Make a website that generates websites. He wrote a piece of software that he sold to Yahoo. It became Yahoo Stores. He made a hell of a lot of money. And then, you know, he and his friends made a hell of a lot of money. He went off and started Y Combinator. You've probably heard of it. It's a famous incubator. Brilliant guy. Wrote a spectacular book with about a dozen essays in it. Highly recommended. All of his essays are online. Go to paulgraham.com. All of his essays are there. But finding the ones that are in the book, he doesn't like say, here are the ones in the book. They're just, you have to find them. But so if you don't want to pay for the book, go online and try to figure out which ones are which, or just go buy a used version of the book for $1.99. It's really, really awesome. He talks about this stuff. And everywhere where he talks about something where I have personal experience in it, and I can say, yeah, that's actually the way it was, he's right. And he speaks more eloquently than I do. And so the guy is really good. So I trust that where he's talking about stuff that I don't know, I trust him. I think he's probably right. So he's really good, and he thinks about this stuff and talks about it a lot. And one of the things that he talks about a whole lot is this sort of like what it means to be a startup and what are some of the problems that you face. You know, and big companies can't really innovate, and you wonder why. Why can't they? But they don't. And startups really must innovate in order to survive. One of the things that happens is that startups are kind of cool because they're dominated by you guys. They're dominated by the people who came up with the technology, and those are the people who get rewarded for the success of the company. The moment that the company becomes more mature, they start bringing in CXOs. You know, CEOs, CIOs, CFOs, whatever. They start bringing in, you know, the C-suite of people and lots of marketing people and sales people and so forth. Those are the people who get rewarded, not the engineers. By that time, the people who have started the company are long gone, and they're off starting another company. Okay, you know, enough from the peanut gallery. So I say anything. No, it's Chris. It's freaking Chris. So anyways, so at this point, you know, the guys who founded the place are gone, and so it's these high-level executives who are making the money, and they're making the decisions, and they're making they're getting the rewards, and their job is not to innovate. Their job is not to screw it up. You got to remember that these guys, their job is don't sink the ship on my watch. Okay, that's their decision-making process. Don't sink the ship on my watch, okay? Totally different from what engineers are doing, which is like, let's conquer the world, let's take risks. You know, I mean, that's what startups are like, okay? So this is why that is true. Issues that face larger startups. So this is like, you know, Boston Technology. You know, they were in the 60 to 250, you know, employee range. Not gigantic, not like 1,000 employees, which would be like many of the defense contractors in the DC area, but you know, still, but not tiny like 10 people. There's a tension. Some of the things. There's this massive tension between marketing and R&D. And because the marketing people are talking to your customers, and the customers are telling them what they're willing to spend money on. Hey, we'll give you a lot of money if you build X. And they're like, cool. And they sign a contract. We'll deliver you that in 3 months. And then they come to you. They come down to R&D and say, hey, we just got $100,000 if we build one of these. And you go, you can't do that. That's impossible. You can't do that. You sure as hell can't do it in 3 months. You know, and you know, very patiently explain to them that no, in order for that to work, light would have to go like backwards in time, and it just can't. And you know, they just don't get it. Like, but I sold it. Yes, of course you did, but we can't build it.
That you sold it because
yeah, it's pretty cool.
can't deliver.
Yeah, it's pretty cool that you sold it for only $100,000. You know, I mean, so literally, this is the kind of stuff that comes in. They say we sold the following thing, and you either show like this is completely incompatible with our products. We have to build something brand new from scratch, or you say that'd be really nice, but we don't have the manpower or whatever. There's this massive tension. Their job is to sell stuff. Your job is to build it, and they think of you as the labor. You know, they're the geniuses coming up with the new ideas, and you're merely the implementers. And that's the way it feels to them. And you have to like you know, have a really strong head of R&D to stand up to them and say, screw yourselves, you know, and you know, so that they back off and they don't feel like, we own your asses, and that's, you know, that happens. You know, it happens. So we have plate meetings. You know, like, what are we going to keep on the plate? We got to kick that off the plate. You know, basically, like, we can't do that. We had this massive list of things that, you know, they were wish items. This is where we finally got people at the head of R&D who were able to stand up to the marketing people and say, okay, I will take your list of demands and we will try to figure out which ones we can do. And then we have these plate meetings where we say, okay, here's everything on the plate. How much of this can we actually do? And we like be throwing stuff out. Yeah, okay, we can do that. No, no, no. Yes, yes, no, yes. Anyways, so you have lots of these things. And then this is where you get judicious and you go like, do we really want to do that? How much money are we getting for this? And is it coming to us or is it coming to those guys? And the truth is it's coming to those guys. So you're like, screw it. All right, here's something from Paul Graham. Always run uphill. This is a great, great concept. And it is, and the idea is simply, if you're trying to figure out, do I do one of these two features? I have enough manpower to do this one or that one. Which one do I do? Always run uphill, meaning do the one that's harder, because you force your competitors to follow you. Now, this is going to your earlier question, young man, I forget your name, Alexander, about how do you protect yourself? We'll get to that later, but one of the ways that you can protect yourself is do things that are difficult to copy. Do things that are difficult to reproduce. Do things that are difficult. If you know it's hard for you, it's probably just as hard for your competitor. So do the thing that's hardest. Run uphill, because you're going to make somebody else run uphill to follow you. Because when people say, which product am I going to buy? Am I going to buy yours or that guy's? And they usually, the people who are making those decisions, just have lists of features. This one has 6 features. Yours has 7 features. I'm buying yours. That's literally what these people often do. They say, yours has more features than that guy's, so I'm going to get yours. So add features, don't just add them willy-nilly, but add features that are really hard to implement, because then you will have features that he doesn't, and you can make a big deal. Even if you know that it's a stupid feature, you can still make a big deal about it. Say, hey, we do X, Y, Z, and that's really damn hard. It's very useful, and those guys don't have it, you know? And that's what Paul Graham talks about. It's really funny, but it's a great idea. This is one of the ways that you protect yourself. All right, issues facing smaller startups. This is like, you know, you and your buddies size, you know, 5 people, 10 people, something really small. The biggest issue facing you is to stay alive. Because, okay, funding is a problem. Also, be able to pivot at a moment's notice, because, okay, well, like the company that I worked for, Priority Call Management, the original idea that my friend had was, what he wanted to do was, I didn't even tell you what it was, did I? It did voicemail, but that was not its main thing. It was a call completion device, where basically people would walk around with beeper, and your beeper goes off, you can pick up any telephone anywhere in the system, and the call gets routed to that phone. It was kind of cool. But it's in the days when, I mean, today you go like, that's lame. Well, yeah, it was because, you know, there was a time when these didn't exist. And if you wanted one, they cost like $5,000. So, you know, nobody had this instant communication feature. You know, if you were away from your desk, you were incommunicado. And so what he was thinking was that we would go to trade shows and large convention centers where they have trade shows, and put our phones in around the periphery of the building, and give people a pager, so that because sales guys are the people who are going to these trade shows, and they live and die by their telephone, you know. And so when they're away from their phone, when they're away from their desk, nobody can get in touch with them. They can't get in touch with anybody, and they're not making money. Their job is to make connections and sell stuff. And so they're out on the trade floor all day long, you know, hey, making contacts and getting business cards. Hey, let's do a deal. Let's do lunch. Let's talk about this. Let's, you know. So these guys are like schmoozing all day long, and then they go home at night, or they go to the hotel room rather at night, like 10 o'clock at night after dinner, and they have like 50 calls from the home office that they need to respond to. And what we did is we put phones in the building such that they could be walking around glad handing people and slapping them on the back. Hey, I was good to see you, buddy. Beeper goes off. Hold on for a second. Then they go pick up the phone. Hello, and it'd be called from their home office in freaking some other state. The guys loved it. They thought it was the best, freaking coolest, awesomest product ever, but they didn't want it. They didn't want to have to stand in line for it. Because they go to these trade shows, and they stand in line for their badge, and they stand in line for their stuff, their bag of stuff, and they stand in line for their drink tickets, and they stand in line for they stand in line for half a dozen things. They didn't want to stand in another line for our service. Be able to pivot. Ultimately, what they did was they decided to sell this thing to companies so that the company could have an officeless office. So that and by this time, cell phones were starting to become inexpensive. You know, you could buy a cell phone for just like a couple $100, and so everybody had them. And so so people wanted to be like not in the office, and so you could hook people's cell phones into this device so that it would call a cell phone, it would call a home phone, it would call an interior phone, it would inside the building, whatever, it would call whatever phone, and that phone would be part of the system. So your cell phone picks up, and you could be like the receptionist on a freaking beach somewhere with a cell phone. You go, hi, thank you for calling Fred Associates. How can I direct your call? And they say, hi, Gina, how's it going? Well, I'm doing quite well. And she's in a friggin' bathing suit in a towel on the beach, and she's drinking Mai Tais. I'm doing quite well, George. Good to hear from you. Who do you want to talk to today? Beep, beep, boop, boop, and sends them off on the way. That was really cool. So this is what they ultimately figured that they would sell the product as, and they made a lot of money doing it. The reason they were able to do it was the genius of the guy who wrote their software. The guy asked me to make a screwdriver. He asked me to make this device to put into conference centers, and I could have made something that was meant to go into conference centers. Basically he said make a screwdriver. Make a screwdriver. I could have made exactly that. I could have made a screwdriver, but instead I made a Swiss Army knife with a screwdriver adapter, a screwdriver blade in it. And I put a couple other blades in just to show how you can add more blades. Turns out that was a really good feature. And they ultimately used that to add up a whole bunch of other stuff without having to touch my code at all. And they were very easily able to pivot into other markets, and they ultimately found this one that made them a lot of money. Be able to pivot, okay? That's important. Funding. Why do most startups fail? You hear the number, 90% of all startups fail. Why? Why do 90% of all startups fail? I told you. It's because usually, it's not because they had a bad product. It's not because they had crappy technology. It's not because they had a bad implementation. It's not because they misread the market. It's not because, it's because they ran out of money. It's because they didn't wait long enough for the market to catch up. Okay? Because you have a brilliant idea. You've seen a problem. You've seen a solution. You've come up with a good implementation of that solution. It looks cool, it works, it's affordable. You are now way steps ahead of the market. You have figured out, this is a problem, here's a cool solution, and I got a good way to implement that solution. Now I'm here, I've got the thing that will solve your problems. Well, the market still doesn't even recognize that it's a problem. The market doesn't know that that's a good solution to the problem, even if they did recognize a problem, and they don't even recognize that your implementation is actually kind of a pretty good solution to the problem that I need. It takes them a while to wake up to it. You're like 2 years ahead of the market. You think all I have to do is present the world with my great idea, and they're going to beat a door to my front door, beat a path to my front doorstep, and they're going to beat my door down, begging for my product. No. Sorry. Doesn't work that way. The market goes, oh, that's interesting. I got other stuff to do, or play my guitar, or my keyboard, whatever. They got other stuff to do. And then like 6 months later, they go, you're still there? That's great. 6 months later, you're still there? What is it that you do? That's great. 6 months later, you're still there? Those are the guys that do the what is it they did? Yeah, that's true. 6 months later, they go, yeah, God, I need one of those. it takes a long time for the market to catch up with you. It takes a long time for them to realize they actually need the thing that it is that you're offering. Most startups fail because everybody goes, screw it, I'm out of here, before the market catches up to them. They either run out of money, they run out of patience, they run out of whatever. The guys are like, this is boring, I want to go start up another company, or whatever. People just, they leave and the company just dissolves, and it's, the market hadn't caught up with them yet. That's it. That's why most startups fail. It's not because of it, it is not because of a bad idea or a bad implementation. It takes a long time for the market to realize you're there. And actually, this guy said it. It's not, you don't succeed when, let me see. It's not when the market realizes you're there. It's when the market realizes you're still there. That's when you succeed. Because you'll come on like a bang, like you'll have like all sorts of news releases, and there'll be like posts on the internet, like, and spots on, I don't know, radio, TV, whatever. This is the greatest thing, and everyone's, that's really cool, and then they're going to go about their daily life because they don't need the thing yet that you're selling. It's when they realize that you're still there. They're still making that thing. Yeah, that's kind of cool. I'll check that out. That's when you succeed. When people start saying, yeah, I'm going to go check that out. That takes a while. And again, always run uphill. It's really important for the smaller startups. And then intellectual property. This is really hard. How do you protect yourself from other people? Protecting your intellectual property is really costly. It costs about $30,000, $40,000 to get a patent. I was lucky because one of my students had a father who was a retired patent examiner, and he was willing to do patents for me for like $4,000, $5,000. So I patented everything I could think about. Everything I could think of, I friggin' patented, until he started realizing that he should be charging like $25,000 instead of $5,000. And all of a sudden I started getting bills that are like 5 to 10 times higher than they used to be. I'm like, what's this? He goes, I decided I should start charging market rates. I'm like, when did I agree to that? And I just like, I dumped him because I couldn't afford a $25,000, $30,000 friggin' patent. So I just basically stopped the whole patenting thing. So patents are expensive. And the real thing is, are they worthwhile? Because yes, they protect your stuff, but they also tell the world exactly how you solve the problem. That's what a patent is. You tell the entire world how to solve a problem in exchange for a limited monopoly. That's the whole process. Have you guys, has anybody ever told you this stuff? Okay, it sounds like some of you yes, some of you no. All right, so the whole point of the patent is you get a limited monopoly, between a dozen and 20 years, on your technology in exchange for you teaching that technology, meaning you tell the world how to do exactly it is the thing that you just did. So that means that your competitors have now caught up with you overnight. The 3, 4, 5 years of R&D that you did to get to that point, they now leapfrog and they are now right there behind you. They can build the thing that you spent 5 years to do, and they can build it overnight. That's the downside of doing a patent. Okay, so you got to decide, do you want to do that or not? You can also just not tell anybody how you solve the problem. Yes, sir.
So a patent, you're supposed to be able to sue other people, other companies, if they implemented something the same way that you patented. So how is it that if a company sees the whole way that you solve your problem in your patent, can't you sue them if they copy your research?
Any good engineer can look at a patent, figure out how to solve it in a slightly different way that isn't covered by the patent.
And if they have a bunch of money with lawyers, they can defend their ways different enough.
Yeah.
Because the patent
Yes.
only covers the exact way that it was done. If you even change like 100 lines of code, congratulations, it's a different program, it's no longer.
Wow.
Yeah.
Can even make it better.
Yeah, software patents is a new
Are
concept.
really, really
Yeah.
difficult. They're
Yeah.
even harder.
Yeah, well, that was the thing. It used to be that software could only be copyrighted And then they started allowing you to patent algorithms, and then people went
Only algorithms.
ballistic,
Like
and
an
then, yeah.
actual code can't be patented.
Yeah.
All
So-
you do is change 100 lines, and then the patent doesn't count for it anymore.
So software is a totally different beast, and I'm gonna take a wild guess that software is way harder to protect than anything else. Just a thought, in my limited experience. Like I said, I haven't done software, but
I think through patents, but it's easier to keep a trade secret because depending on the type of security things, it's harder to reverse engineer, whereas any mechanical device, you can just take it apart.
sometimes though, the mere announcement of the fact that your thing does, just the mere announcement of the features will tell smart people how you solve the problem. Like, you know, if I tell people what these guys are capable of doing, smart people can figure out exactly how I did it. Just because, you know, they didn't think it, they did. The thing is, when you don't know if there is a solution to the problem, there's an infinite number of choices that you could take. And so solving it tends to be a very difficult thing. If you don't know there is a solution. The moment someone tells you, I solved it, your brain does this weird switching thing where all of a sudden you go, oh my God, I bet they did this. Holy crap, how'd you go from infinite to knowing what it is? Simply because you knew, somebody told you, I solved it. It goes from like infinitely difficult to, oh my God, I bet I know how to. It's crazy, but this is the, you know, how the brain works. It's wild. You can ask a question.
Oh, no, I was gonna say, instead of doing patents on like your code, a lot of companies just have their employees sign NDAs.
Yeah.
So that, like,
yeah,
you don't.
So yeah, I mean, I honestly, I don't know the best way to protect ideas because it's, you know, there are good points and bad points to all of this.
It's a foggy gray area.
Yeah, it really is. More on funding. So this is funding is something something that I'm you know, I have a lot of opinions on. But this is something where I don't like most entrepreneur web workshops and so forth, like the ones that were up in DC. They were always about writing a business plan and getting funding. You know, that was Entrepreneurship 101, and it was like how to write a business plan, how to get venture capitalism. It's like, what? No, that's like, you do that much later. You know, the first thing you should do is figure out what thing to build, figure out how to build it, you know, figure out the problem to solve and how best to solve it. So this, don't worry about money because that's putting the cart before the horse. Know that if you take somebody's money, you are going to give up at least 51% of the company. At the absolute least, you're going to give up 51% of the company, and you will probably give up closer to 99% of the company. You're lucky if you only give up 90. If they let you keep 10% of the company, you're lucky. The only way that you can get closer to 51 and further away from 99 is if you wait longer. Have a more mature company. Have a more mature product. Not need their capital as much. So that's why you don't want to go looking for venture capital right off the bat. You go for venture capital right off the bat, you're giving up 99% of the intellectual property. They're going to take 99% of the company. You will be left with 1%. Why? Because they're funding everything. They are taking the financial risk. What should you do? If you have 20 bucks, and it's your money, how long can you make that 20 bucks last?
What am I doing
If
with
I
it?
give you 100 bucks, how efficient are you with it? You'll piss right through it. If you use your own funds, I guarantee you, you will be able to last on, I don't know, 5, 10 grand of your own money or money you borrowed from your parents or your aunt and uncle or whatever. You will last longer on 10 grand of your own money than you will on $1 million of venture capital. And I say that not because I know any of you, but because I've seen what idiots do when they get $1 million. They get, woo! They throw a party and they get, lots of alcohol and,
And then there's no more $1 million.
and then they buy like, a $200,000 spot on television for an advertisement. And it's just like, oh my God. I'm sorry?
And it doesn't do anything for
And
them.
it doesn't do anything for them.
Then congratulations, you no longer have any more money.
Exactly. Well, precisely. That's what I'm saying. Use your own money as long as you can. Yes.
So you can get money from venture capital, or you can use your own money. Is there any way to like avoid getting venture capital, but still using like other people's money to fund something?
Well, so what my friend did was he sold stock to family and friends. And so, but I call that your own money. Because you're going to people who are not trying to screw you. They're saying they're friends, their family. They're willing to take a financial risk on you because they believe in you, and they're like, give the kid 10 grand, give the kid 15 grand, something like that. Yeah, they'll take a bit out of savings and hand it off to you for a percent of stock of your company. Not that it's going to go, oh yeah, they're all prepared to lose every penny of what they've given you. They're just really freaking nice, and they're wealthy enough to be able to afford it. I call that your own money. That's what my friend did. So he pulled together, I don't know how much he got. It was something on the order of 100 grand or so. That he sold stock to friends and family. And he made it last a long damn time.
Did that company succeed?
I'm sorry?
Did that company that he got funded, did it succeed?
That was, oh, you weren't here at the beginning. That was the company that was sold for $160 million.
Okay, good. That worked for me.
Is that success enough for you?
Yeah, that's success.
Yeah, that was pretty successful. It was in 1999, right before the crash.
That would have sucked. To kind of go off of his point, would you say that something like Kickstarter would be a mix between venture capital and your own?
Oh, it's entirely like your own money, because Kickstarter gives you the money. You have there's actually no restriction. You basically, yeah. Okay, so good point. Actually, excellent point. It is a blend of both, because here's the thing. It's money that you don't give up any of your, excellent point. I'm glad you brought that up. You don't give up any of your company in order to take that money. However, it's mentally somebody else's money. So it's very easy for you to piss through it, because it's something that, you didn't have to work for. Somebody just gave it to you. So.
Oh my God, there's so many failed Kickstarters.
Yes, so it's you just need to be very, very careful and pretend that it's your own money, and be really diligent with it, but it really is in between. It's got the best and worst aspects of both. The one good thing is you don't give up your company for it. So in that regard, it's like your own, but yeah, the problem is it comes too easy. And the danger is you piss through it because you failed to account for costs or whatever. But there is that danger. So just make sure that you figure out your costs really well ahead of time. What else do we have? Oh, and then, yeah, to repeat, yeah, we talked about that. I don't need to say it again. Yeah, so basically use your own. It'll last longer. And again, use this if you have to. But again, Kickstarter is really good because it'll give you a good idea if people actually like your idea and are willing to fork over their cash for it. All right, so I think that's all I got. So bottom line, anything that's in your head today should be in your hands tomorrow. Anything. I mean, it's wild. You can anything, whether it's a cool RC car design or RC plane design or an actual automobile or golf club design or whatever, someone will make for you. If you have a good design, someone will make it for you. It's, they'll do it. So, yes, sir.
How do you advertise your products once you felt like they were complete?
I got really lucky. It was ready over summer. And summer is a period where in the DC area, nothing is happening. Absolutely nothing is happening. I mean, like, there's no news. at all, usually in the summers, like on like non-election years, and this was a non-election year. And summers are generally so dead that like if a congressman sneezes, it it shows up on the news, and it's just like just anything stupid shows up. And so we waited until there was a silence, and the University of Maryland put out a press release about it. Everybody took it. I mean, it showed up in the freaking LA Times, it showed up in the Washington Post. I was interviewed on TV and radio and everything because there was nothing going on. Absolutely. I was interviewed on freaking NPR. I went down to NPR. I was interviewed by Siegel. What do you call All Things Considered by Siegel. And I brought this guitar with me, and his tech was a PRS fan. He was an actual what is the word? He was a gigging musician on the side. He was the audio tech for the radio show. And Siegel was like, I'd like my tech to play your guitar, and his guitar, and this guy was like, I'll play your guitar. And so he was waiting for it to be an absolute piece of crap, because this is some professor who has an idea, he can build a guitar. And he played it, he goes, that's not bad.
And that's why timing is one of the most significant factors.
Yes, so we got lucky. We got very, very lucky because that's, I had the university behind me. They put out the press release, and it was just a really down week where there was absolutely nothing going on. It was just like, holy crap. I could have done like, Professor Jacob does butterfly collection, and it was, oh my God, those butterflies. It was just like, we got very, very lucky.
It was one of those weeks.
Yeah, exactly. It was one of those weeks. Nothing's going on, and everyone's just dying for news. So try to do that. Yeah, I don't know how you plan something like that, but we got very lucky. I would say, well, I've heard. So Alex was telling me about there's this cool stuff where you were taught by Justin Heacock how to use. I'm sorry?
With Phoenix Flights.
With Phoenix.
It was an internship that basically they did here.
Okay, so basically he taught you guys how to use Google Ads for targeted market research. That's also a really cool way to both advertise and figure out what people like.
Because if you create a landing page, then you can do a sales funnel, and then basically you have them go through a series of clicking links. Of basically like, I'm interested in your product. How many people click that? Okay, how many people click, I want to buy it? And then after that, how many people actually enter their email and say, yeah, I want to buy this product when it comes out. You can see how interested people are at every level.
Yeah. So there are lots of really cool ways to advertise, because that's advertising. There's a lot of cool ways that really didn't exist 20 years ago when I did this. So I'd say that, people are really internet savvy these days. Google Ads are how a lot of people find a lot of stuff. I bought these damn things because I kept seeing these Tecovas ads, pop up every time I did a Google search. I'm like, oh, cowboy boots. I'm gonna try getting cowboy boots. It's just like after you see it 300 times, his point of sale dipshit. They feel good. I'm gonna wear these. So there are really good ways to get ideas out there these days, and I think Kickstarter is actually a really good one, because that's a great advertising platform, because you put this really cool thing out and it gets sent out by people's Twitter, and there's just a lot of really good avenues for advertising your stuff that didn't exist before, and I'm not great with them, but I do know which ones affect me, so I would go with those. I don't know who was first. He was first. All right.
I'm curious, how do you fund your guitar company working here?
I worked for a startup company that was sold for a lot of money, and I got a small percentage of a lot of money.
And so you use that personal money to fund your whole guitar company? Okay.
That's another reason to go into the startup industry. There's a small chance that you'll make a lot of money, or at least a small percentage of a very large amount of money. So, yes.
Question. So that strategy you did with the University of Maryland, do you think a university like this, with its size, would be willing to push a product out?
I think they would. I think they absolutely would. So the difference is that I don't know how big and or sophisticated our PR department is here. I think they
We have
probably
a
are
better
because.
one, we have a pretty good one, I've spoken with them.
Okay, because I mean, I know a lot of people who tell me that we've got great web presence, great videos and great, you know, really good materials online. So somebody's making that stuff. I think if we had, you know, so like startups.portapoly.edu or something like that, where, you know, we
list of businesses.
yeah. So, I mean, I think that would be a good thing, like entrepreneurship.portapoly.edu or whatever, where, you know, people could go and find stuff and the company could link, or the university could link to it or whatever. Yeah, I think that the university would probably be willing to do that sort of thing. I don't know. Frankly, I don't know who's in charge of entrepreneurship now that, you know, Peacock is gone. You know, I mean, I'd be willing to do it, but they haven't asked me to do anything. And I think the data science and business analytics department wants to do, I think they want to be the owners of entrepreneurship, but I don't know.
So I have a question that I was wondering before. So if I have an idea, what should I do if I have an idea that I think would be reasonable or useful, but I don't necessarily have the technical know-how at this time or yet, and you know, maybe I don't have a lot of money to hire other people. What should I do with that idea?
Either take classes so that you get the skills, or collaborate with other students who do have those skills, and, you know, see if you can join up and turn into a group. One of the things that's really useful is if you do like freshman groups oriented things, or other classes where you've got group oriented projects, or senior capstone design where you're doing groups, you're going to be forced to interact with other people in a multidisciplinary. Well, it's nice because it's a multidisciplinary thing. Now, you guys know this graph right here, right? Where so you know, productivity versus the people in a group. You guys know that. So let's say, you know, here is how productive a group of size 1 is. And as you start adding people to the group, you become, you know, more productive in a roughly linear fashion. You know, double the people, the number of people in the group, and you get roughly double the productivity and so forth. You guys know this, right? So at some point it saturates, and at some point it starts to actually go down. And in fact, it asymptotes to 0. It's true. That's why it's freaking funny. This, organically, it's about 3 people, 4 people. You're lucky if you find 5 people who can work together and be 5 times as productive as 1 person. You are lucky. It's usually 2, 3, maybe 4. But by the time you have about 5 people, you're over here. 10 people, you're down there. You might as well just be 1 person doing the job yourself. And the big trick, I don't know, it's not a trick. The reason that companies like Intel, AMD, Microsoft, you know, you name it, the reason that they are successful is they enforce design rules on their engineers to push this out. They force teams to work by not making you screw up, you know, not allowing you to screw up in ways that an organically grown group would. You know, they limit the amount of communication. They formally define the interfaces. They formally separate the modules so that there's less communication, and, you know, all the communication happens up front where you divide the design, and then, you know, everybody can then go off and work in parallel. You know, that's basically how they that's how they have 100-person groups that are actually 100 times faster than one guy doing it by himself. You know.
So they're basically splitting up the group into lots of smaller groups that work well together.
Well, no, it's kind of like what they do is, like when you guys collaborate, you just sort of like informally get together and start working on stuff, and you keep talking about it, and you meet every week and you talk about problems you're having, and then there's almost guaranteed you guys don't have the formalism that you see at Intel. You know, the hierarchy that you've got at Intel and things like that. Almost certain that you don't do that. And so what companies like Intel and so forth do is they have a formalism for how the design will be split up. There's like one or two guys at the top who design it, they divide it, they start separating it out and do formal interfaces between the pieces, and then they farm out the work to people so that everybody can do work in parallel and not have to communicate. Okay, because it's the communication that kills you. It's not because people are dumb, it's the communication. What happens down here is you start spending so much time talking to each other and meeting and figuring out solutions to problems and going, oh my God, I thought you were going to do that. Who did this? Oh, you find all the things that fell through the cracks and whatnot. You spend all your time talking and not building. And that's what happens, you know, once you have a bigger group. And so what the big companies do is they figure out how to make that not happen. But it's not by any stretch of the imagination an organically formed group. It is a very, very rigidly formed group, and the guys at the top say, you will do this, here you go, here's your work, and everybody goes off and they do their stuff. And lo and behold, that huge team of 200 engineers actually gets the thing done 200 times faster than you could do it by yourself. It's really impressive, really impressive. You don't have a whole lot of individual freedom of creativity or, you know, input to the overall picture. But, you know, well, that's the downside of work. And it's one of the things that happens in a really, really, really big company. If you know, with a bachelor's degree and a master's degree, you're hired in at the bottom to be an implementer, and the only people who are at the top doing the design stuff are guys who have PhDs and years of experience. You know. But that's like when you go into a business that's got, you know, 50,000 employees. So.
Right, say you have a startup and it's
Your battery's about to die.
Oh shit! I totally forgot to plug it in, didn't I? Well, I'm pretty much done at this point, yeah. Because you've read this.
Yeah.
Yeah. Okay. Cool. I can just shut it off. So, all right, thank you. Questions? All right, cool.
So you have a startup and you're about at the phase where you got something, say version 3, which is kind of okay, not the greatest, but you want to start like marketing it to people. You don't have a lot of money. So would it be better to focus the little amount of money you have left on making your product better or putting that towards marketing?
I think that what you want to do is get the product right. But that's me. And it worked for this. You know, I spent a lot of money getting these things right. And then, you know, I put them in people's hands and said, here, play it. And they go, yeah, all right. Oh, shit. And I mean, it was wild. I mean, every time we put one in somebody's hands, they bought it. But then we got really sick and tired of having to put them in people's hands. Nobody wanted to be a salesperson. Everybody wanted to be an engineer. We all wanted to design them. Hey, let's design. Hey, and then people would be drawing like shapes. Hey, can we make this shape? Hey, can we do this switch? Hey, can we do this? You know, everybody was designing stuff. Nobody wanted to go out and sell.
So you know how many people you're working with, like say it's you and 2 other people.
Right.
Like none of you like know marketing. You're all engineers.
You might want to bring in a sales guy. You know? And when it comes to so here's another thing to think about. You got to think about, you know, market size and money and costs and so forth, because it's just you. Just round numbers. Say, okay, I got to sell. How much money do you want to live off of? And just do just round numbers. 100 grand. I need to be able to make 100 grand. So do the rough, you know, back of the envelope calculations to see how much do you need to sell in order to make $100,000. How much product do you need to sell? Because it's different. If you're selling something for $1,000 a piece, well, that means I got to sell 100 of them a year. If you're selling circuit boards for $5 a piece, well, $5 into $100,000, that's a hell of a lot of circuit boards. So figure out the thing it is that you're selling. How many do you have to sell to make 100 grand? Because that's sort of, the minimum of what you would want to say. That's my startup company. That's what I'm going to do for a living. You can live on that really well. Okay, cool. You're going to bring in a partner. Now you got to sell $200,000 a year. You're going to bring in another friend who goes, oh, dude, can I participate? Oh, and another one goes, oh, yeah, and he's got a great car and he can drive. And suddenly now, all of a sudden, you got a bunch of people involved. Now you got to sell $900,000 worth of stuff.
If you split the profits evenly, but.
Well, yes, but. Okay, so.
You get 50 grand.
Yeah, so at some point, you say, okay, we got to stop bringing in founders who will be splitting it evenly. And you say, you're an employee. You get a small amount of stock and I will give you cash. So the founders don't actually get any cash. Founders don't get any crap. Okay, you get, what happens when this company stops losing money. Then you as a founder start making money. But up until that point, you don't get a salary, you don't get crap. Every penny that is in the company needs to stay in the company because you're trying to develop the idea, do some marketing, pay for advertising, and so founders don't get anything until the company stops losing, hemorrhaging money. But you might want to say, okay, let's keep the number of founders at whatever, and we're going to hire this dude at $15 an hour. Now he costs 30 grand, not 100 grand. But you got to pay him in cash. So that's not part of the costs. So paying yourself 100 grand, that's not part of the costs. That doesn't happen until you're actually making enough money to pay yourself 100 grand. So you see what I'm getting at? So these are the calculations that you want to do, and be careful about how many people you bring in, because I was like, okay, I could do this, and I could actually do this by myself. And then I told some students, and all of a sudden 6 students were like in my office thinking that they're part of it. I'm like, oh, how do I tell them no? And so I'm like, sure, you can be part of it. Oh God, okay, great. Yes, this is gonna be awesome. How the hell am I gonna sell $600,000 worth of stuff? And I'm like, at that point, I'm like, okay, this isn't a real startup company. We're not gonna make money. I just want it to pay for itself. And that's all. I just wanted to prove the idea at that point. Once I brought in other people, I'm like, there's no way, because I could have done it, but I'd have to quit my day job in order to do it. It'd have to be you got to put a lot of work into it. And so that's sort of my thinking at the time. So be careful how many people you bring in and make part of the family.
Part of that question is trying to figure out how important, would it be easier to learn marketing yourself for the company?
Well, so there's 2 things though. There's marketing and there's sales. Marketing, I think you can figure out. Marketing is like, will people hand over? Yeah, will people hand over cash for your thing?
If you're confident, you can market.
Yeah.
Marketing is
figuring
you
out.
can just talk about it. If you sound confident, you will sell people.
Yeah. If you know it and you love it and if this